Now we are going to solve one numerical problem based on a Gauss forward central interpolation formulae. So in order to save the time, here we already write the what? Here we already write the question. What is the question? Question is using Gauss forward central difference formula, find the value of F32 from the following data. So from the given data, first of all, we construct the central difference table, or you may say equivalently we construct the forward difference table, Gauss forward central difference formula. First we write a Gauss forward central interpolation formula. What is the Gauss forward central interpolation formula? Y equal Fx equal y0 plus u del y0 plus u minus 1 upon factorial 2 del 2y minus 1. How many number of data here? 1, 2, 3, 4. So there is a need there we able to calculate only a third order forward difference. So here we write only a up to a third order forward difference. We write a Gauss forward interpolation formula up to a third order forward difference. So here this one is a u plus 1 u minus 1 upon factorial 3 del 3 y minus 1 del 3 y minus 1. All other term there is no need to calculate all other term, because del fourth order forward difference means if there is a 4 data, then fourth order forward difference become 0. What is the value for u? Basically u equal what? U equal x minus x0 upon h. X0 is a what? X0 is a central value. So here how many number of a data? There is a 4 data. So there are 2 central values. You may consider 30 as a central value, also 35 as a central values. So for sake of simplicity, we consider the 30 as a central value, means x0 be the 30. So if x0 be the 30, you may also consider, again we repeat this statement, you may also consider the x0 be the 35. But if we consider the x0 be the 30, then what is the value for u? U equal what is the value of x? X is a 32. There is a need to calculate the value of f at x equal to 32. Here we write 32 minus 30 upon h. H is a what? H is a class interval. Difference between second data to first data, 30 minus 25 or 35 minus 30, 40 minus 35. These values are equal to h. So what is your h? H is a 5. So this one equal 2 by 5. So u equal 2 by 5. So if we have a value for u, there is a need to calculate the value for del y0, del 2y minus 1, del 3y minus 1. So for this one, there is a need to construct the difference table. So in order to save the time, already we construct the difference table. So this one is a difference table. So here we try to explain this difference table. This one is a value of x0. If we calculate not x0, because we say that what? We say that central value, here we assume that this one is just x0 and this one is a what? X minus 1, this one is a x1, this one is a x2. Central value with the x0 and corresponding value with the, this one is a y0, this one is a y minus 1, this one is a y1, this one is a y2. This one is a given values. This one is a given data. At 25, what is the value? 2707. Here we write at 25 the value is a 0.2707, at 30 0.3027, 35 0.3386, at 40 0.3794. Then difference of a y1 minus y0, this one equal nothing is y1 minus y0. This one is a y1 minus y0, y1 minus y0. You may write this one y1 minus y0, you may write this one is a what? Not a y1 minus y0, because here difference of these two, y0 minus y minus 1, y0 minus y minus 1. This one is the difference of a y1 minus y0. y1 minus y0. This one is difference of a y2 minus y1. This one, this one, this one, and this one. In terms of a forward difference operator, you may write this one is a what? Del y minus 1. This one is a del y0. This one is a del y1. Similarly, difference of these two, this one equal to what? Del 2y minus 1. This one is a del 2 y0, and this one is a del 3 y minus 1. So, which values are required in a Gauss forward interpolation formula? There is a need to central value. Central, this one is a central value. This one is a central line. You may also say this one is a central line. This one is a central value. So, this one is a central line. This one is a central line. This one is a central line. So, which one is a central value? This one is a central value. Here, this one is a considered as a central value. This one is a considered as a central value. Then next to the central line, this one is a del y0. Then again, this one is a central value. This one is a next to the central. This one is a what? Forward. This one is a central value. Here we consider this one is a central value, and again this one is a central value. Means you may decide on the basis of a central line as well as what? As well as in the formulae there is a need to values of y0, del y0, del 2y minus 1 and del 3y minus 1. So, here we encircle the values of y0, del y0, del 2y minus 1 and del 3y minus 1. Just we put these values in this formula. So, with the values of a u, what is the value of a u? The value of a u is a 2 by 5. So, what is the value? The value become y equal f of 32 equal y0. What is the y0? Y0, if we sake of a simplicity, once again here write the formula y0 u del y0 plus u minus 1 upon factorial 2 del 2 y minus 1 plus u plus 1 u minus 1 upon factorial 3 del 3 y minus 1, del 3 y minus 1. Just we put the values. What is the value of a y0? This one is a 0.3027 plus what is the value of a u? U is a, what is the u? U is a 2 by 5. U is a 2 by 5. 2 by 5 into 2 by 5 minus 1 upon factorial 2. What is the value of a del 2y minus 1? Del 2y minus 1 is a 0.0039 plus 2 by 5 plus 1, 2 by 5, 2 by 5 minus 1 upon factorial 3 with a 6. Del 3y minus 1 is a what? 0.0010. So, after simplification of this one, already we write the values after simplification of each term, this term, this term, this term. So, u del y0, we have not write the u del y0, sorry. So, here we again we erase out this one, we erase out this one, we erase out this one, and here we write factorial 2. The values of y0 be the 0.3027 plus u 2 by 5 del y0 be the into 0.0359 plus 2y5 minus 1, but now next we come factorial 2, del 2y minus 1 is a 0.0039 plus last value with a 2y5 plus 1 2y5 minus 1 upon factorial 3 with a 6 del 3y minus 1 into 0.0010. So, after simplification there are 4 terms. First term is this one, second term after simplification of a second term, third term, fourth term. So, with the help of a calculator we already calculated these values and write down in order to save the time. This one is a values after simplification of a first term. There is no need to simplify this term because the value is a 0.3027. If we divided this one by the 5 and multiplied by the 2, then this one is a value. This one is a value. After simplification of a third term, this one is a value. After simplification of a fourth term, this one is a value. After adding this one, we able to find out 0.31653. This one is a value of F32. So, what is the summary of this lecture? In a central difference interpolation formula, we use the central values. In a forward central value, if there are two central values, then next to the central line, means if there are two values, then last we use the last value. And if there is a one central value, means if there is an odd number of terms, obviously there is a one central value, then we use the central value. If there is an even number of terms, then there are the two central value, then we use the last term, then again central value, then again last value, then again the central value. Or in other words, we say that we draw a central line, and always in a forward interpolation formula we use the central value and next to the central line, means a value which is belong on a central line, or if value does not belong on a central line, we choose next to the central line. And using the Gauss, or you may say Gauss forward interpolation formula, in order to find out the values nearer to the central values. So, as we know that always we use the Gauss forward interpolation, means a forward interpolation formula, not a Gauss forward interpolation formula. Forward interpolation formula, we try to interpolate the value nearer to the first value. We use the backward interpolation formula nearer to the last value. We use the central interpolation formula nearer to the middle value. So, in the next lecture, we try to explain, means we try to solve some more numerical example based on a Gauss backward central interpolation formula, Stirling interpolation formula, Laplace Everts, as well as Bessel's interpolation formula. These formula, as we know that these formula with a central interpolation formula. So, thank you joining my lecture. Thank you very much.